Welcome, ladies and gentlemen. Today we are on one of my favourite maths topics. We are on to what's called the null factor law. And essentially what we want to learn to do today is actually use this law called the null factor law to actually allow us to solve quadratics and essentially determine their roots or their x-intercepts. So what we're going to do is we're going to recognise once again that the x-intercepts of a graph is where the function is equal to 0, and that if we multiply numbers that equal 0, then either of the values is 0. And we're going to go into that in a second. So what the null factor law tells us, if we multiply two numbers together and they equal 0, then one or both of those numbers must be 0. So in order for, let's just say B is, so if A, B equals 0 and B equals 12, then A times 12 must equal 0. Therefore, A must be 0. There's no other option that's going to get us to a 0 answer. Conversely, if A was 23, then B must equal 0. So essentially, if two numbers multiply to 0, then one or both of those must be equal to 0. So for example, here we've got A plus 3 times B is 0. So therefore, A plus 3 must equal to 0 or B is equal to 0. If A plus 3 is 0, then A equals negative 3, because we're going to subtract 3 from both sides. So if we were to do a check on this, so remember A plus 3 times B equals 0. Well, A plus 3 times 0 equals 0. So that would work out quite fine. Our other option was A, which was negative 3 plus 3 times B equals 0. Negative 3 plus 3 is 0 times B is going to be equal 0. So it's going to work out for us. So moving on, we can bring this into some more complex equations. So here we've got two terms, x minus 7 and x plus 11. So if this entire equation equals 0, we know that x minus 7 equals 0, or x plus 11 equals 0. So with our rearrangement, x equals negative 11 or x equals 7. Once again, let's check. If I substitute 7 in for x, this will equal 0. If I substitute negative 11 for x, that side will equal 0. So this works out. What about over here? I've got x squared minus 3x. Now I need to have this in a factorised form for this to work. So I could factorise out an x. So x outside of x minus 3 equals 0. So therefore x equals 0 or x minus 3 equals 0. So x equals 3. So my two options, x is 0 or x is 3. What about if I have a quadratic? And this is where we've been doing so much work on our factorisation, because what we want to do is try and put this into a factorised form. So once again, this is a square number. We've got x squared. This is a square number. We've got 3 squared. So and 6 is 2 times x times 3, and then we have a negative. So we could directly factorise this into x minus 3 squared equals 0. So once again, if we've got, this would be x minus 3 times x minus 3. But either way, when we square root, remember when we square root we have a positive or a negative. So a negative or positive 0 is still 0. So we can directly go into x minus 3 equals 0. So x equals 3. Also remember with this equation here, if we've got x minus 3 squared, how did this look when we looked at sketching from turning point form? Because this is now in what's called turning point form. That would be our h value, our k value would be 0, so therefore we had a turning point at 3, 0. What about over here? We've got x squared plus x minus 6. Square number, not a square number, so it's not going to be a perfect square. So we're going to have to look at splitting the middle term. So our a value is 1, b is 1, c is negative 6. AC is negative 6 plus b is 1. So we're going to multiply to a negative number, so we have to have a positive and a negative, and we're going to add to a positive number, so our bigger number is going to be positive. So we could have 6 and 1, which is going to give us 5, 3 and 2, which is going to give us 1. So we've got x plus 3, x minus 2 equals 0. So therefore we've got x plus 3 equals 0, or x minus 2 equals 0. So x is 2 or x is negative 3. Let's do a couple more. So we've got here, this time we've got a coefficient which is not 1 on our x squared, so we're going to have to make sure we do our full factorization. So we've got our AC, our plus b, so AC is 2 times negative 3, which is negative 6, our plus b is 1. So once again, we're multiplying to a negative number, which means we've got to have 1 negative and 1 positive. We're adding to a positive number, so therefore our larger number is going to be positive. So we can have 6 and negative 1, 3 and negative 2, and this one's going to work out. So we'll split our middle term, so we have 0 equals 2x squared plus 3x minus 2x minus 3. Can't really factorize much here. So we just got our x outside of 2x plus 3, and then we're going to have to get a positive here, so we're going to have to pull out a negative 1. So 2x plus 3. So 2x plus 3 is our common term, and what's left is x minus 1 equals 0. So now we can use our null factor law. And we've got 2x plus 3 equals 0, or x minus 1 equals 0. So 2x equals negative 3, or x equals 1. So dividing by 2, so x is negative 3 on 2, or x equals 1. Moving over here, we have got the difference of two squares. So we've got x squared. Actually, no, we don't have the difference of two squares because we've got a plus. Trying to trick me up here. So with x squared plus 9, it's actually a little bit simpler because we just have a rearrangement. X squared equals negative 9. So with this situation, we would say, well, x equals the square root of negative 9. So when can we square root a negative number? Never. So this has no solutions because we can't square root that negative number. So if we were to graph this equation, it's actually going to, so remember it's x squared plus 9. So our in our turning point form, this would be x minus 0 squared plus 9. So our turning point is here at 0, 9, and it's just going up vertically because our a value is a positive. What about here? 2x squared minus 32. So let's see what factorization we can do initially. So we've got a 2 outside of x squared minus 16 equals 0. Now we have our difference of two squares. We've got 4 squared and x squared. So we've got 2x minus 4, x plus 4 equals 0. Now, 2 can't be equal to 0 because 2 is 2. So using our null factor law, x minus 4 equals 0, or x plus 4 equals 0, x equals 4, or x equals negative 4. Okay, so our significance of our null factor law, which I have talked about a little bit as we've gone through. So remember, when we're plotting, we had our key features. We had our turning point of our parabola, our y-intercept, and our x-intercepts. And we're using our x-intercepts where we set, so remember, x-intercepts are at y equals 0. So if I'm setting my y as 0, 0 equals x minus 4, x plus 2. So null factor law, x minus 4 equals 0, or x plus 2 equals 0. I can solve out and go, well, where are my x-intercepts? They're at negative 2, 0, and negative 4, 0. Negative 2, 0, and 4, 0. So by using my null factor law, I can quite easily, from a factorized equation, determine where those x-intercepts are. So let's look at a problem solver to try and do an example here. So the height of a football after being kicked is determined by the equation negative 0.1 d squared plus 3d, where d is the horizontal distance from the player. Determine the maximum distance that the ball can be kicked. So in terms of doing a quick sketch, we've got a y-intercept, so rather our height is here and our distance is here. By looking at this directly, we've got no c value at the end. D is our value. So we know we've got a y-intercept of 0. We've got a negative a value, so we know it's going to be a frowny face. So we know it's going to look something like that as an equation. So the distance that the ball can be kicked is going to be when the ball hits the ground again. So what we want to know is, what is the distance from here to here? Or the distance between our x-intercepts. So we need to determine what our x-intercepts are. So our x-intercepts are at h, or the height is 0. So 0 equals negative 0.1 d squared plus 3d. Let's just factorize. So 0 equals 0.1, so d outside of 0.1d plus 3. So then we can use our null factor law. So null factor law, d must equal 0, or 0.1 d plus 3 must equal 0. So from here, 0.1 d, negative 0.1 d equals negative 3. So I did miss the negative in front here when I factorised down. So now we can divide by negative 0.1. So d equals 30. So we've got 0, 0 and 30, 0. So the distance is the difference of the x-intercepts. So it's going to be the 30 minus 0, So we're going to kick the ball 30 meters. Therefore, the distance is 30 meters. So what we need to look now at is what are our assumptions or limitations. So number one, we're assuming that it is traveling in a perfect parabola. Number two, we're assuming that the ground is flat, because if it was a sloping field, the ground level may be lower. We're also assuming that the parabola works out, there's no wind, all those sorts of things. So that's our null factor, that's an example of it, and enjoy your problems.